Hi, everyone. My name is Mayur. I'm a PhD student at the University of British Columbia in Vancouver, Canada. And in this video, I'll be presenting our WACV paper, which is titled HistoMILKD, a multiple instance learning-based multi-teacher knowledge distillation framework for whole slide image classification. In the last couple of years, there has been a surge of foundation models in digital pathology. And as of today, there's over 25 foundation models out there. And each of these foundation models, when used as a backbone for feature extraction, leads to different levels of performances on different downstream tasks. And there so far has been no clear consensus of a superior go-to foundation model. One way to get rid of this model selection problem is to ensemble all the foundation models. While this does improve the performance and gets rid of the model selection problem, the resulting model is too bulky, and this hinders the feasibility of its application. Which is why in this work we use a multi-teacher knowledge distillation framework that not only keeps the knowledge of all the foundation models, but also the resulting model is not as bulky as the ensemble model. In fact, the resulting model is as big as the individual foundation model. The prior works in this research area deal with natural images, especially the ImageNet data, where the images are of size 512 by 512. Whereas in our case, we deal with whole slide images that are as big as 100,000 by 100,000 pixels. Some other works develop smaller foundation models using self-supervised learning strategies. But the problem with these models is they, again, need to be fine-tuned for the downstream task. So our contributions in this work include the HistoMILKD framework, which is the first multi-teacher knowledge distillation framework for whole slide image classification. We integrate the multiple instance learning paradigm to handle the gigapixel resolution of the whole slide images. And our experiments on 5 public datasets show that the proposed model outperforms the individual foundation models as well as the ensemble model and the competing approaches. So here is a pictorial overview of our methodology. As you can see, we start with the whole slide image and we use the patches as the inputs to our model. The T here denotes the teachers. So here, for example, we have N teachers trying to distill knowledge into the student network, which is denoted as S. So each foundation model is pre-trained and frozen. And we include the multiple instance learning framework to aggregate the the patch level features to obtain slide level features, which are then passed through linear layers to get a prediction. We also used an autoencoder-like network to reconstruct the teacher features based on the student feature. And accordingly, we use multiple loss functions, including the mean square error loss, the cross entropy loss, and the KL divergence loss. If you're interested in our work, I highly recommend checking out our paper to get more details about the loss functions. While the model does look bulky during training, during inference, we only use the student network, which is as big as the individual foundation model, except that in this case, due to the knowledge distillation, it contains the knowledge from the foundation models that were used during training. Here is a quick summary of our results. We divide this table into 3 stanza. The first is where we have the individual foundation models. And as you can see, across 5 datasets, there are different foundation models performing well, underscoring the model selection problem. And then we have the ensemble model, where, as you can see, the combined size is the sum of all the foundation models. And the results are better than the individual foundation models. And in the final stanza, we have the multi-teacher knowledge distillation approaches. The first 5 here are the prior works that deal with natural images. And in this work, we benchmark them on the histopathology domain. And finally, we have our proposed work, which outperforms all the prior works significantly in most cases. So here's a quick summary of the interpretability of our model. And as you can see, this is the student model heat map, which used to be an incorrect prediction. And after knowledge distillation, we have a new heat map and a correct prediction. And the new heat map aligns with that of the heat maps of the correctly predicted teachers. And in conclusion, in this work, we propose HistoMILKD, the first multi-teacher knowledge distillation framework for whole slide image classification. And we have strong empirical results that support the use of multi-teacher knowledge distillation for enhancing the foundation model capabilities. And as future work, we want to test this approach on external cohorts to further validate this approach. Thank you for listening. And if you're interested in our work, please check out our GitHub page where we have the code and the paper. Thank you.